Hello student, welcome back to Power Electronics. In this lecture, inshallah, this is lecture number 2. Inshallah, we will introduce to you the uncontrolled single phase half wave rectifiers. And in single phase half wave rectifiers, we will see and we will outline the introduction, and we will see how the rectifier is acting with resistive load, and we will take some waveform. Inshallah, we will draw together. After that, we will see the same rectifier with RL load, resistive and inductive load. And we will see some problem with the inductive load the half wave is facing. Then inshallah we are going to fix this problem with the freewheeling diode. And at the end of this lecture you will see a homework. You can do it at home. And if you have any questions regarding the homework or the lecture, inshallah we will take it, and I will answer you in the discussion sessions, inshallah. Now, what is a rectifier? We know that the rectifier is a converter, and it is converting from AC to DC, right? And the purpose of the rectifier is to have an output DC. Of course, it is not purely DC, but at least it is not AC. We know that an AC wave is like this. This is AC wave, right? Now this is AC wave, and this is DC wave with big value, let's say 3 volt, and AC wave here, let's say here we have 3 volt also. Okay, now this is DC, right? And here we have AC AC wave. Okay, now in half wave rectifiers, you will see the output is changing and trying to get rid of the negative portion here of the AC, and it will be zero like this. Inshallah, I will explain why it is zero, and it is trying to convert the signal into DC, but it is not, of course, it is not a pure DC. Now, in half wave rectifiers, they are most used often in low power applications. Of course, low power applications, because the average current for the supply will not be zero. And also the applications in practical يا شباب, in practical applications of this circuit is limited. In practical, for half wave rectifiers it is limited, but inshallah we are going to understand step by step converters, and how can we rectify the signal from AC into DC, starting from half wave rectifier until we are building up information until we reach three phase full wave rectifier, three phase half wave rectifier, and so on. Okay. Now, the objectives of the chapter are introduced in general analysis techniques for power electronics circuits to apply the power computation concepts of the previous chapter. Now, this is our half-wave rectifier circuit. Here we can see that we have an AC supply, right? This is an AC supply. Vs is V maximum equal to V maximum sine omega t. Why sine? Because it is a sine wave. Okay, so this is a sine wave. Okay, we know that this wave is changing with time. That's why we have time here. Okay, that's why we have time, because the value of the voltage is will be different at each point. Let's say here the peak value 3 volts. Here at this point at t equal to pi, which is 180, right? The value of the voltage is 0 volt. Now this is 0 volt, right? So that is why in AC circuits we have the term of sine omega t, okay? And of course V maximum, because it will give you the peak value. Now just let me erase rotate this one, please. Okay. Now we have a diode here, right? And we know from electronics that the diode is a silicon material, made of silicon, yes, and it has an anode here and cathode here. Anode is always positive, cathode is always negative. Okay, then we will have our resistive load. Okay, for the first, then this is the V out. Here we can take the output voltage, and it will be DC. This is AC, and here we have DC output across the resistor, of course, right? So the supply the supply circuit or supply waveform is like this. All right, I'm going to draw it here, okay? This is our supply. This is an AC wave. Okay. This is our supply. Let's say this is our voltage. Here our voltage, and here with time. Okay. Now, for the first part, shabab, let me just introduce you to the AC supply here. The AC supply, it has positive cycle, right, and negative cycle. So we have positive cycle and negative cycle, right? Now, please concentrate on the circuit here, shabab, on the circuit. Now, I'm going to draw for the positive cycle first. Now, we have positive cycle from the supply is going like this. Now, this diode is forward bias because we have plus here and plus here. So, it is forward bias, right? So, it will allow the current to move. Okay, so we have current here now, and then it will go through the load. Okay, and it will come back to the source. Now this is for the positive cycle. Now this is our positive cycle. Can you see here the blue color? So this is our positive cycle. So it will reach to the maximum, and then it goes to 0, right? Now, for the current, now I'm going to draw the current with the green color, okay? For the negative part, now for the negative part here, shabab, this is the negative part, okay? Now, of course, it will go from minus, right? Now we are going from minus. Let me draw it like this, okay? I will go from here. I will go up, right? I will go through the resistor, and I will go here. Now, the diode is reverse bias. The diode here now is reverse bias, and it will act like what, ya shabab? It will act like open circuit. So it is open circuit. So the current will not move, right? No more. So there is no current because the diode is reverse biased, and it will act like an open circuit, and there is no current. That's why we have here for the voltage is 0 here. Can you see? Here in the waveform we have 0. So the negative part here is removed. The negative part here is being removed. It is 0. It is 0 now. Okay? So we have positive cycle only. The negative ripple here is removed. That's why we have a half wave. So we have one pulse here. Okay? So this is for the this is for one cycle. This is for one cycle. Now, of course, the current, if we have, if the diode is forward bias, of course, the diode will be acting like a wire, and then it will conduct, and we will have our current. It is the same as the voltage. It will start from zero and until its peak. Okay, the same peak. I mean the position at 90 degrees or pi over 2, and it will go to zero again. Of course, because of the open circuit here, when the reverse bias is coming, then we will have zero current for the negative supply, for the negative supply. Now this is the principle of the diode. This is the principle of the diode. Now in this circuit, as you can see, we have one diode, right? Now if I ask you in the exam, okay, what will be the what will be the voltage across the diode? What will be the voltage across the diode, right? We have VD, right? Here we have VD. Now, what is the voltage across the diode? Of course, if we have a supply like this, okay, this is our supply AC, and we get rid of the negative, right? It will be zero. Now, of course, the diode will be the voltage on the diode will be the remaining of the power supply, So when the diode is conducting, there is no voltage, of course, because it will act as a wire, and the potential difference between the 2 points of the diode is zero, so there is no voltage. Okay, so once the diode is reverse bias, there is an open circuit. Remember, there is an open circuit here. Then we have a potential difference between those 2 points. Then we will have voltage. Of course, it will be the voltage of the supply. So this is the remaining of the voltage of the supply. This is for V diode, huh? This is for V diode, voltage of the diode. Now here, as I explained, this is the voltage output and the current output. Draw it here together with you. I will make the supply with the. Let me just use the supply with the blue color. Okay. Now this is our y-axis, and this is our x-axis, right? Suppose that we have here our peak value for the voltage. Okay, so 1 here, 1 2 3, so 3 boxes. Then 1 2 3, here we have here we have pi over 2. Okay, and 1 2 3, here we have our pi, right? And 1 2 3, here we have our 3 pi over 2, and 1 2 3, here we have our 2 pi, right? Okay, so we can, if we need to draw, ya shabab, inshallah, you may be asked in the exam to draw the, let's say, the supply waveform. Then we will draw it like this. You need to divide the squares here with the convenient numbers. Then we put the peak values. Okay, now of course here, of course, will be 0, and it will start from 0, right? And here we will have our negative peak value. So this is 1, this is 2, this is 3, and this is our negative peak value. Okay, and of course it will return to 0. So we can draw like this from up to down. okay, from up to down يا شباب. Sorry, from up to down. Yeah, now then it will go like this from, yeah, and it will go like this, and this is our AC supply. AC supply, this is for the voltage, this is V maximum, but this is for the supply, for the supply. Now if I want to draw the current, I will draw the current with the red color. Okay, of course it will start from 0, and its peak will be the same as the peak of the same position at the peak of the voltage, but it is half. Okay, so we can say this is our peak for the current, and it will come back to 0, and this is our peak of the negative current, and it will go to 0. So we can just connect the point together. Okay, and then it will go to 0. So this is the peak, I maximum, yeah, and again it is for the supply. Now this is how to draw the supply circuit. Of course the supply waveform, it will be given for you, but I want to just only to show you how we can draw it together. Okay, now if I use I want from you to draw the output voltage for the half wave rectifier, uncontrolled rectifier, we can say that it will be like the same as the what يا شباب, same as the positive cycle of the supply voltage, right? So I'm going to draw with the green color. Okay, so it will be the same 1 2 3. Okay, and we will go to 0 because the positive cycle is conducting, right? And it will, this is pi, and we need to go to 0. Excellent. So this part is here now. Okay, now of course from pi until 2 pi we have what? We have 0 volt, right? We have 0 volt because it is half wave rectifier, as we explained there. Now this is how to draw the voltage V out. We can say this is V out, right? This is V out, this is DC, this is V out DC. Okay, now for the current I'm going to draw it with an orange color. Okay, now again the current will be the same as here, but it is half, so this is our current, we can say, yeah, and it will be here 0 up to 2 pi. So this is for the current for the I out DC. This is how to draw it, right? And it will be also half wave. We have one pulse because the other pulse will be the diode will be reverse bias, and it will act like open circuit. Then there is no current, of course. That's why we have 0. So we get rid of the negative portion of the supply. Now for the diode, voltage of the diode, this is our x-axis. Now for the voltage of the diode, I'm going to draw it with the red color again. Okay, for the diode we know that once the output voltage, or once the diode is conducting, it will act like a wire, and there is no voltage on the diode. There is no voltage, so we can draw until pi here. There is no voltage. Now once the diode is acting as a reverse bias, then it will act like an open circuit. Then we will have our voltage, of course, if we get rid of the negative portion. So the diode, the voltage across the diode will be the remaining of the supply. So this is our remaining supply here. So this is 1, 2, 3. Okay, we can return to 0, and here return to 0. So this is our V diode. This is our V diode. Okay, this is how to draw the three waves. Okay, if I ask an exam, you should do it like this, and identify how to. Please make sure that you understand how to draw, and that's it for the resistive load. Now, if I want to calculate V out, شباب, if I want to calculate V out, then of course V out is the same as the V average. V out is now DC, right? V out is DC. So if you see V out or V average, they are the same. Okay. Now, the equation for V out is this one. So 1 divided by 2 pi, integration from 0 to pi, okay, because it's half wave. V maximum sine omega t d omega t, okay, and it is equal to V max over pi. So the final answer is V max over pi. So V out is equal to what? V max over pi. That's it. Okay. If you need to see how did we get V maximum over pi, you can refer to the explanation here, the derivation of the equation, and I'm going to explain very fast. Now this is our V out here, 1 over 2 pi, integration from 0 to pi, V maximum sine omega t dt, d omega t. Now, we know that this is a scalar part, which is a number. That's why we're going to take it out. Okay, we'll take it out with the with minus. Why is that? Because sine, the integration of sine is minus cosine. Is minus cosine. So we took the minus outside. Okay, and the remaining is cosine omega t. Now we can take, of course, it is from 0 to pi. Then again minus V maximum over 2 pi here. Okay, we will take it, and then we will apply pi first. So cosine pi minus cosine 0, because from 0 to pi, right? This minus is from the equation. Okay, we know that the first part is the end of the integration minus the starting of the integration, right? And this is from calculus. You can refer to the calculus. Now cosine pi is minus 1. Now, how can I know it is minus 1? You can do it with the calculator, or you can refer to this graph. This graph says that it will divide the circle for 4 points. This is point number 1, this is point number 2, 3, and 4. Now, if we go to point number 1, the left side number is for the cosine, the right side number is for the sine, okay? And this is at 0, okay? 0 angle, and here at pi over 2, here at pi, here at 3 pi over 2, and if we return back, it is 2 pi. So 0 and 2 pi, the same angle. Okay, so he said cosine pi. So at pi, the cosine is minus 1. So that's why it is minus 1 here. Now cosine 0 is here. This is 0, right? So cosine is 1. Okay, so minus 1 minus 1. So minus 2, right? Now, if we multiply minus, of course, the 2 will be removed with 2, right? And minus will be multiplied, minus is positive. So V maximum over pi. This is how we get our equation. So V maximum over pi. Okay? Now, this is the derivation. This derivation is not required. Let me write it here. Not required. okay? But this is just to let you know that we can get the final answer. This is the final answer. This is our final answer. So V out, this is equal to V out DC. Okay, so V out, if I ask what is V out DC, it is V maximum divided by pi. Okay, now if we refer to Ohm's law, we know that current is equal to V over R, right? Okay, so I out is equal to V out over R, right? What about V out? V out, we said it is V maximum divided by pi over R. So it is V maximum over pi R. So this is our I output. This is our I output. Inshallah, we will take examples and you can see it in the examples. Now, the average power absorbed by the resistor can be computed from those equations. Of course, those equations from circuit 1, we know that power is equal to I square, RMS multiply R, resistance, and of course square, I square, and equal to V square over R, okay? Now, this is the equation for the VRMS. So if I ask you in the exam what is the VRMS, you will tell me that it is equal to V maximum over 2, V maximum over 2. And again, doing Ohm's law, you will get IRMS is equal to V maximum over 2 pi. Okay, now if I will explain to you the derivation of the VRMS, okay? Now this is our VRMS here, guys. Okay, so it is square root of 1 over 2 pi integration of integration of V maximum sine omega t from 0 to pi square d omega t. Now, as we said, V maximum is a scalar quantity, so we can take it out. Okay, we'll take it out like here, and of course with the square, and then sine is already squared here, right? Now sine square from calculus, the quantity is equal to what? 1 minus cosine 2x divided by 2, right? This is if it is sine x. If it is omega t here, sine square omega t, it is 1 minus cosine 2 omega t, okay, divided by 2 d omega t. Now we can just take 1 over half here, okay, and this part also we'll take it here like this, and we can take 1 over 2 aside like this one, okay. Now after that, we know that the integration of half here, the integration of half, okay, is half omega t, because if we are going to integrate 1, okay, d 1 dx, okay, with respect to x, then it is 1x, okay. That's why it is like it is half omega t. And then with the using calculus, we know that cosine 2 omega t is basically we multiply by 2 and divide by 2. So 1 over 2 multiply 1 over 2 cosine 2 omega t. And if we multiply 1 over 2 multiply 1 over 2, then we will get 1 over 4 cosine 2 omega t. Now this is for this is our answer here. Then we substitute 0, pi, and 0 and pi. The first part is pi, and then we go to 0 minus. So we substitute omega t with pi, so half pi, right, minus, this is from the equation here, minus sine 2 pi, right, 2, and omega t is pi, so we write here pi. Then minus from the equation, okay, half of 0 plus 1 over 4 sine 2 of 0, right? And this is, of course, this means 0, this part is 0, this part is 0, so we just have root and root of 1 over 2, right? And after that, after we finish from this derivation, we can say that this pi is removed with this pi, right? Because it is multiplication. And 1 over 2 multiply by 2 here. So we can multiply them and it will be 4. And V maximum. Of course, if we get rid of the 2 here, and it is V maximum. And 4, if we take the square root of 4, it will be 2. So this is our final answer, which is V maximum over 2. Of course, again, it is not required. Okay, so it's not required, but this is just only to show you how we get the final answer. Okay, now let's go to our example. Example 3-1, it is from the book. You can refer to the book, the textbook. He said that for a half-wave rectifier of figure 3-1, this is our figure, okay? The source is a sinusoidal of 120 V RMS. Make sure you understand this one, Shabab. This is RMS value. It is not the big value, okay? It is RMS value. Now, at a frequency of 60 Hz, he said that the load is 5 ohm, okay? Determine the average load current. Now, we know that the average load current, I out, is equal to V out over R, right? And V out is basically V maximum divided by pi divided by R. Of course, it will be like this, and we can take this one down. Then V maximum over pi R. Okay. Now, how much V out? V out is not given. We have V RMS, right? We know that V maximum is equal to root 2 V RMS. Okay, and root 2 multiply V RMS is 120. So we will get our answer here, Shabab. So this is our V maximum, 169.7. So we can say it is root 2 multiply V RMS divided by pi over R. So this is our final answer. It is 10.8 ampere. This is for the current output DC, right? Now, for part B, he said the average power absorbed by the load. And we know that the average power is basically V RMS square divided by R from circuit 1, okay? Now we need to calculate VRMS. Now VRMS, VRMS, yes. VRMS is V maximum divided by 2. VRMS is V maximum divided by 2. Why is that, Shabab? Because it is half-wave rectifier. We will get half of the wave, right? It is half-wave rectifier. So from the equations, I think it is there. Let me just go back to the equations. Yeah. So this is our equation, Shabab. If we refer this equations you can find it in the notes. So if as it is mentioned there, VRMS. So VRMS is V maximum divided by 2. V maximum is divided by 2. So V maximum divided by 2. V maximum is root 2 multiply 120, which is 167, 169.7. Divided by 2, it is 84.9. And we can apply this one is here, and we will get 1440 watt. Okay. Now for part C, he said the average or the power factor. Now we know that the power factor is basically P over S. P is the active power, S is the apparent power. Now P is already found here يا شباب, which is 1440. For the S يا شباب, S the apparent power is basically V multiply I, because apparent power, the unit is the apparent power unit is VI, right? Volt ampere. So it is basically voltage multiply current. RMS voltage multiply RMS current of the source, right? So 120 multiply 17. Now how can we get 17? 17 is from Ohm's law يا شباب. This is Ohm's law. The RMS current is basically V maximum divided by 2 R, which is V RMS divided by, let me write it here, V. So I RMS is basically V RMS divided by R, and V RMS is equal to what? V maximum divided by 2 divided by R, and it is V maximum divided by 2R. Okay, so this is how to get 17 ampere. Okay, now we apply the formula and we will get our power factor 0.707, and of course the power factor does not have a unit, so it is like this, and we finish from this example. Now for the resistive inductive load, okay, why we introduce inductive load يا شباب? We know that the inductive load is found in the industry, and it is found in motors. That's why we are going to present half wave rectifier with inductive load in order to see in order to see the output DC voltage and current, and we'll see the effect of the inductive load here. Now from Kirchhoff voltage law, we know that the V maximum, this is the source, is basically the voltage of the resistive plus the voltage of the inductive. Okay, so this is our source. This is our source supply, the supply waveform. So we have positive cycle and negative cycle, and positive portion and negative portion, and this is one cycle. Okay, now for the positive cycle of the supply, then the voltage of the output voltage, we will have a positive here, right? So let me write down with, I will do it with the with another color. Okay, let me do it with the blue color. Okay, now it will be like this. Of course, why is that? Because it will conduct. Okay, it will conduct because it will be the tide will be forward bias for the positive cycle. This is our supply, this is our load, right? So for the positive cycle, it will the diode will conduct, and we will have our voltage, okay, as the same as the supply. But we have problem here. Now for the positive cycle, this inductive load is going to charge with current. Because of the Faraday's law. Faraday say that if we have an inductive load, okay, we can refer to this this rule يا شباب. If we have inductive load, okay, if you have a coil, then a current going pass passing this coil, this current is going to produce a magnetic field around this coil. Okay, this is a magnetic field. Okay, so the inductor is going to charge with current, and with charge with current, of course, and then it will charge for the positive cycle as a magnetic field. For the negative cycle, of course, this diode is open circuit, right? Now the polarity of the inductive is going to be changed. Okay, and it is going to discharge. It is going to discharge, and it will return to the supply. Now this is the issue of the inductive load here. Now what will happen? So it will discharge until it stops. Okay, of course, if it is going to discharge current, of course will be voltage. There is a voltage, so we will have a negative portion here, and this is an issue with the inductive load. If we have a negative portion here, then the output voltage will be less. Okay, and inshallah we are going to fix this problem. Now for the current here, we can use the red color. Okay, of course the current is going to be for the positive cycle, it will charge, the diode will pass the current, and then it will start going to 0, and it is after pi. It is pi plus theta, right? So beta now, our beta is bigger than 180. Our alpha is 0, and our beta is bigger than 180. Okay, because of the discharge of the inductive load. Okay, because of the discharge of the inductive load, and then the rest of the wave will be 0 because it is a half-wave rectifier. And for the voltage of the diode here, of course, once the diode is conducting the current, once we have conduction here, shabab, then it will be 0, as we explained. And then because of this negative portion here, shabab, we will have our the remaining of the supply voltage, and it will be like this. We can draw the peak, and it will go to 0. Okay, this is for the diode, and I need to conclude something here very important. Now, because of the inductive load here in this circuit, the inductive is going to charge for the positive cycle, and for the negative cycle, the inductive load is going to discharge this current and voltage, and we will have a negative portion, which is very bad for our output voltage. Okay, I think you have seen it in the practical, and you saw that in the practical we have less voltage and output voltage, okay, from the resistive load only. Okay, now in order to fix this problem, this current, okay, we need to do what? Something called freewheeling diode. Freewheeling diode. Now, this is our freewheeling diode. Let me just go for the positive cycle. Okay, the positive cycle with the red color, okay? Now, this is our source. This is D1, and here we have D2, and we have RL load, okay? Now, in positive cycle, we have positive cycle going from here. Of course, the diode is forward bias now, so the current is going to the diode is going to allow current, so it will go like this. It will not go down. Why is that? because it is here what يا شباب anode the cathode, and it is now the diode is what is the reverse bias. So it will go from here through the load, and it will come back to the negative of the supply. خلاص. Now this is our source. Okay. Now we finish from the positive cycle. Now if we go to the negative cycle, it will go from here, okay, and it will go through the load, right? It will come back here, and here it will not go because there is open circuit, right? Because of the diode now is acting as a reverse bias and acting as open circuit, then this inductive is going to be the polarity of the inductive load will be opposite now, right, in order to discharge, right? So for the positive cycle, the inductive is charging. The negative cycle of the supply, the inductive is discharging. Now in this case, the inductive is going to discharge like this. It will not go to the supply, it will go through the diode here, and this diode is forward bias, and in this case this is reverse bias, so it will go like this. So for the negative cycle, we will have current circulating here until it is finished. We will see how it is working inshallah in this graph. Now let me just draw the supply. This is our supply, right? Now for the positive cycle, this is our supply here. This is our V output. This is our V output. It is the same as the supply voltage, but it will not go to the negative. Remember this negative? No, it will not go to the negative. No. Why is that? Because we said that the current is going to be discharged through the load. It will not come back to the supply. So the negative part is being removed. Okay? And it will go to 0. Now for the current, it's different. For the current, the current is going to be smoother now. The current is going to it will continue moving, because once the positive cycle is finished, and the negative cycle of the supply is working now, the diode is acting as open circuit, and the inductive load is going to discharge. So this is the amount of discharge until it goes to 2 pi. Okay, so this is how the current is acting with the freewheeling diode. So we fixed the problem, alhamdulillah, and we almost get the V out is like the half-wave rectifier with resistive load, and you can see it in the practical sessions. Okay, of course, if the current is if the diode is conducting the current, then there's no voltage. Okay, after that, the retaining of the supply voltage, it will be here. The remaining of the supply voltage will be here. Now this is for the freewheeling diode. Now there are some advantages for the freewheeling diode. You will take it in the practical session. Okay, now this is your homework. Please refer to this table in order to solve the questions here, and refer to the handout in order to answer the questions in page 35. So this is a question. We have a load here. Load is 25 ohm, a supply voltage which is 110. Okay, it is RMS. If I didn't give you, shabab, if I did not give you the if it is RMS or peak, of course it will be RMS. If I did not mention, it will be RMS. Now, of course, the supply frequency is 60 hertz. Okay, please find those quantities, and these are the final answer. These are the final answer. Okay. Please ignore those two questions يا شباب. Ignore this. خلاص, no need to do it. Thank you so much for attending this lecture, and inshallah we will see you in the coming lectures for full wave uncontrolled rectifier, single phase full wave uncontrolled rectifier. Thank you so much. If you have any questions, please ask me in the Telegram group or in the coming discussion sessions, inshallah. Thank you so much and stay safe.